Oh.
All right, so let's try a few examples and make sure we got this. And then we got to talk about hypothesis tests, but for two samples or two proportions. Okay. All right, so let's do this. Okay. Okay, so I'm going to say it is believed that 30% of Americans like
Are not overweight.
That's probably more than 30%. Who does?
I said are not overweight.
Are not overweight? Okay.
Oh wait, I thought you were commenting on what I said. Never mind.
Yeah, it's believed that 30% of Americans like popcorn. Yeah, probably more than that, but let's just, this is our problem, okay, our example. Okay. You want to know that's true. So you randomly sample 150 people. Alright, so this is our problem. Just slide this up. Okay, I think for the interest of time, I'm just going to work through the answer here, but I'll talk out loud as I go through it, okay? Explain along with it. Okay, so here it says 30%, we believe, okay, it's believed that 30% of Americans like popcorn, okay? But we want to know, is that really true or not? So we surveyed 150 people, and 55 of them said they like popcorn, okay? So from our sample, what is the proportion that like popcorn?
36, I think.
Okay, so our sample proportion.
Oh, wait.
Okay, what's the symbol that we use for the sample proportion? P hat. Our sample proportion is going to be 55 divided by 150, and you said that's 0.366? Okay, so 0.366 is bigger than 30%, right?
Yeah.
Okay. So does this provide evidence that more than 30% of Americans like popcorn?
No.
Maybe, maybe not. Okay, we got to go through a hypothesis test. Okay, so I'm going to set up a null and an alternative hypothesis. What is my null hypothesis and what's my alternative? Remember, the null is what we default to, and we're trying to use evidence to support the alternative. The default is that 30% of Americans like popcorn. So how would I write that? I'd write the proportion of Americans that like popcorn is 30%. So what does that look like symbolically? What symbol do I use to represent proportion of a population? P. So I would say P is equal to 30%. Okay. And the alternative is what?
P less than 30?
Not less than.
Or more than 30?
P is greater than 30.
Which is what we got, the 0.366, right?
Yeah. Okay, well, it's because I'm asking the question, does this provide evidence that more than 30% of Americans like popcorn? That's the question I'm asking. All right.
No, more.
Huh?
More.
Yeah. Okay. So, I'm gonna just so it sinks into our head, all of this thinking here. Yeah, yes, sir, we got a question.
HR just means what we think, and HA means what we want to find out.
No, just think of this as the null hypothesis and the alternative, okay? And we always use data to support the alternative, okay? Don't try to make it more complicated than that, all right? I know you're trying to simplify it in your brain, but by coming up with these kinds of things, you're going to just make it more complicated, and it's going to come back and haunt you. Yeah.
So we're just trying to find, like, we're just trying to prove the alternative, and if not, then we go to the null.
Yeah.
Okay.
Okay, or not prove, but just support the alternative.
Support,
okay.
okay.
And then so the ideas behind this is that, and you don't have to write all of this, but we're gonna write 30%. The null hypothesis states that 30% of Americans like popcorn. And what it implies is that if our sample gives us a proportion different from 30%, it is purely a result of random chance. Okay, that's what the null hypothesis implies. So it says the null hypothesis is that 30% of Americans like popcorn, and if our sample gives us something different, and it did, it gave us 36.6% or 0.3666, whatever. It gave us something different. But what this is saying is that it's just a result of random chance. Every time I select 150 people, I'm not necessarily going to get 30%, the exact same people, okay? Oh, well, of course I'm not. And I'm not going to get exactly 30% liking popcorn. I might get something different. Or, the alternative could be true. It's that, you know, it's not 30% of Americans like popcorn. It's something else, okay? And the alternative says that the reason we see a proportion different from 30% is a result of random chance plus the fact that the real proportion of Americans who like popcorn is bigger than 30%.
And that's when you reject null and accept alternative.
Hang on. Okay, so we haven't rejected it. So it's either this is the case or this is the case. Okay, these are the two possibilities of what could be happening in the world. Okay, and we're going to look at our data and say, does our data support the alternative, or is it just not enough to reject the null? Okay. So maybe we don't have enough evidence to say the null is not correct. Or maybe we do have enough evidence to say the null is wrong, so we're going to go with the alternative. Okay. So let's try to find our test statistic and p-value, okay? So the test statistic in this case is basically our z-score, okay? So in the future, we're going to get something other than a z-score, but in this case, our test statistic is a z-score. What goes in the middle of my distribution?
3 points, okay. 0.366.
0.30.
0.30 or 0.366?
0.30.
0.30, because it's this is the distribution if the null hypothesis were true, right? We asked what's the p-value, what's the probability of observing this if the null hypothesis were true? What is our null hypothesis? Is that the proportion is 30%. So we put 30% in the middle. We want to know what's the probability of getting 0.366 or something greater. And so I have to figure out my standard error.
Wait, which one is your test statistic?
It's going to be the z-score. The z-score is going to be the test statistic.
So we have to find that.
We have to find that.
And then the p-value?
Is what our z-score gives us, right?
Okay.
Okay, so here our standard error is what? So 0.3 times 1 minus 0.3, so 0.7 divided by 150. I don't know what this is. Calculator people, help me out.
0.039.
Point what?
039.
039. Okay, so my z ends up being 0.366 minus 0.3 divided by 0.039. That's going to be close. What do I get?
1.69.
1.69? Okay, I get a z equal to 1.69. Oh, I forgot. What is, we have to select an alpha. We have to select an alpha or a significance level.
Before doing this?
0.5.
We're supposed to do it before we
Oh
choose.
yeah, that's step 2, isn't it?
That's
Yeah.
step 2.
Yeah.
Okay, so what do we want to choose? 5%? Okay, that's not 0.5, that's 0.05. Okay, so we'll choose
0.0.
choose alpha equal to 0.05. All right. Now we can debate whether or not that's a good choice for alpha, but let's say we choose alpha is equal to 0.05. Okay, so sorry, we get z is equal to 1.69. This is my test statistic. What is the p-value?
So you go to the normal.
So you go to your normal table, and because this thing is greater than 30%, that means because it's a greater than, we go only in the above the I'm at a loss of words. Above the cutoff line, okay?
To the right.
Yeah, we go to the right because it says p greater than. If it said p less than, we go
Yeah.
to the left,
Yeah, yeah.
okay? And then we'll talk about what happens when it's
So-
p not equal to.
That's
So it's 0.
0.9545.
Yeah.
Okay, so I get 0.9545, which means over here I have 1 minus that,
Yeah.
so 0.0455. 0.0455. And that is my p-value. Okay, so my p-value is equal to 0.0455.
Ah,
Is this okay with everyone?
Yeah.
This is the probability. What is the p-value? It's the probability of observing your data or something more extreme if the null hypothesis were true. So if truly 30% of Americans, only 30% of Americans like popcorn, the probability that I select 150 random people and see that 36.6% of Americans liking popcorn in this sample, the probability of that happening just by random chance is about 4.5%. So now we make a judgment call. All right. At this point, is my p-value bigger or smaller than alpha? My p-value is less than alpha. So what do? Do I reject the null hypothesis, or do I not reject it?
So it is.
I reject.
Reject null
I reject.
hypotheses.
Okay. P-value is less than alpha, so we reject. And what does that mean? Okay, we accept the alternative. What else does that mean? It means we have evidence that what? We have evidence that exactly that the proportion of people who like popcorn is greater than 30%. Alright, I know that was a lot. Okay, but I tried to do this methodically. So study this example, okay? And then you're going to see things in the book that are similar. And in the book, there's pros and cons to everything, right? I think the book tries to break everything down into little pieces and ask separate questions on each of the little pieces. That's good because it breaks it down. But at the same time, it can also be confusing because you lose the big picture. Okay, so sometimes if you lose, so there's good and bad. Okay, so study the book, but if you get confused, try to fit everything into what the big picture is saying, and then we'll go. Okay. Yes, Sarah. Not random. I mean, maybe arbitrarily. Yeah. That's just the most common choice of alpha is 5%.
Is that gonna be good?
Huh?
Is that gonna be good?
Yeah.
So-
on the test on quiz, like, how do I?
Yeah.
what
Okay,
alpha
so,
is in the
alright. So if alpha is never stated in a problem, use alpha 5%. Okay, that's kind of the default value.
Okay.
But, or maybe in the test or quiz, I will say use this particular alpha. Okay? So if I said alpha is 1%, you would not reject the null because your p-value is bigger than alpha. Okay? Yeah.
And in what cases would you use the less
Smaller alpha and bigger alpha.
Right.
Yeah, we'll talk about that not today, but in a week or two. Okay? Because the implications of what using a big or small alpha changes. Yeah, David.
If our numbers happen to come out wrong, like our standard deviation, by a few ticks.
Yeah, if it's off by a few ticks, no problem. Okay. Maybe on the final exam, if it's multiple choice, you kind of have to make a judgment call. Is this one tick off? Then it's fine. Okay. Yeah, don't worry about that. Okay, I got more to say here. So let me just talk. All right. So just regarding the alternative hypothesis. Okay. So in this case, we had p greater than 0.3. So when we did the shading, we went to the right. Okay. So p is greater than some number. In the picture, shade to the right. So if this was our picture, we shade to the right. Okay. If the alternative is p is less than some number, in the picture, shade to the left. So you shade on this side. Okay, or more likely, maybe it looks like this or something.
I think so.
Hmm?
Nothing.
And then if the alternative is that p does not equal to, and it's some number here, okay? And remember, whatever number you put in the null hypothesis is going to be the same number that appears in the alternative. You're never going to have two different numbers. It's going to have the same number, okay? So in all cases, use the same number that appears in the null hypothesis. Okay? And the null hypothesis will always have an equal sign. Always, always, always. Okay, so for not equal to, what happens is, wherever the cutoff is, just shade into the wedge, okay? Shade the wedge and then double it, okay? Shade the triangle piece, for lack of a better word, and then double. So, and that technically gives you the lower side, okay, because it's symmetric. So, I know that feels weird, but it'll make sense. It'll make sense, okay? Just like driving a car, the first time you get behind the wheel, it feels a little awkward, you're uncomfortable, and then now you're driving down the road and you fall asleep. Not fall asleep, but you zone out and you end up home and you're like, how did I get here? Okay? Things will become automatic with the more exposure and training you do, okay? But the first time you're all nervous and you're like, right? So, okay. It's okay. Yes?
I keep messing up on the difference between the P and the P hat. Like earlier when you asked if it's 0.30, 0.36, 366. I did the same thing on the quiz where like I messed it up.
Yeah, that's a tough, it's a tough one. I don't know if there's a simple answer, okay? Well, for hypothesis tests, your standard errors will always use whatever appears in your hypotheses, okay? So, maybe these are just some tips. Okay, the standard error will always use the value in the hypothesis. So, example, if the null hypothesis says P is equal to 0.30, then your standard error will be 0.30 times 0.70 over, n. Okay? So that's gonna be one case, okay? And then whatever occurs in your null hypothesis, this will serve as the mean in your normal distribution, okay? The value in the normal null and the hypotheses will be the mean in the normal distribution.
But you didn't specify which hypothesis.
Well, it's the same number in the null and alternative,
Okay.
so it doesn't matter.
So that mean would be the one that would be going in the middle.
Yeah, the
Okay.
0.30 goes in the middle.
Okay. Thank you.
But when you read a problem, all I can say is just pay attention and try not to get your sample proportion mixed up with the actual proportion. Okay.
Okay.
But yeah, that's just
When you say HA doesn't, P doesn't equal the equal sign
Uh-huh.
slash, when would that, you guys, equal, like, when,
Yeah, so that's whenever the words different, not equal to, change, things that don't imply direction, okay? And there's a lot coming at you, okay? And we'll revisit a lot of these things in the coming weeks, okay? So today it's just like blah 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 blah, and it's like, and I'm gonna cover even more stuff today, all right? And I know it's like, oh man, this is the worst ever, but I am obligated to cover a certain amount, so yeah. Okay, so that will wrap it up there, and there's a little bit more in the books about stuff, and you'll have some homework problems, and yeah, it's gonna be uncomfortable this first time you're doing hypothesis tests. You're gonna get stuck and you're gonna get confused with things, and we'll try to work through them. Okay. All right. Okay. So now, so this is the next section, and then we're gonna do hypothesis tests. For two
nugget.
Or we'll just call it for two proportions. Okay, so alright, I got a lot to cover. I got about half an hour left, so try to ask questions. But that's don't stop me too much. Okay. All right. So we're dealing with two proportions, and what this looks like is we're gonna say, maybe there's a question like, is the proportion of people who watch American Gladiators, okay, is it different for men and women, okay? All right, American Gladiators is not on the air anymore, but that's a great show, okay? So maybe, okay, so we're like, do we believe that the same proportion of women watch American Gladiators as men watch American Gladiators? Yes, no, okay, maybe not. So that's what we're testing here, okay? So our null hypothesis states that the proportion, okay, and we're gonna write P1 minus P2 is equal to 0. What this says is that the proportion of group 1, or men who like American Gladiators, minus the proportion of women who like American Gladiators, or whatever group 2 is, that the difference between them is 0, that there's no difference between the proportions. Okay? There's no difference between the proportion of group 1 with some trait. Okay, so in this case, group 1 is men who like American Gladiators. There's no difference between the proportion of group 1 and the proportion of group 2 with the trait. Yeah, with the same trait. With the same trait. With some trait and with the same trait. Sure. Alright. And then the alternative is that there is a difference, or that the difference is bigger than 0, or that the difference is less than 0. It depends on, so P1 is the proportion of men who like American Gladiators, and we're subtracting out the proportion of women who like American Gladiators. Do you think this is going to be bigger than 0, less than 0, or not equal to 0? What should we use? Not equal. Okay, so here, by saying not equal to, we are not sure whether it's men or women who like it more. Okay? By using it greater than, we're suspecting that group 1 likes it more, and by using less than, we're saying group 2 likes it more, or whatever trait we're looking for. Okay, so not equal to 0, or or greater than, or less than. Okay. So when we do this, okay, the process is still the same. You choose an alpha. Okay, so step 1 is the hypotheses. Step 2, you still pick an alpha. Step 3 is find your test statistic and p-value. So let me here. This is where it gets weird, and just like more stuff. It's like you just learned how to drive a car, and now we're gonna put you into stick shift, okay? Keep track of all of this other stuff on top of all the rules of the road. Okay, so but you can do it. You can do it. Alright, so under the null hypothesis, if the null hypothesis were true, what value do I put in the middle? 0, okay? And what this is saying, alright, this is the distribution of any time I take two things and I calculate the difference, okay? if there truly was no difference between the proportion of men who like American Gladiators and the proportion of women who like American Gladiators, okay? Whenever I take two random samples, let's say I sampled 100 men and I said, do you like American Gladiators? And I sampled 100 women and I said, do you like American Gladiators? I would expect the difference between them to be 0. But sometimes, because it's random sampling, maybe today I happen to pick more men who like American Gladiators and fewer women, so now I get a proportion that's bigger than 0. Or maybe on another day, I get more women who like American Gladiators than men, and so now my proportion, the difference is less than 0, okay? But we're expecting 0 to be the most common number, or the number that appears in the middle. What we end up seeing is our data ends up showing something else. Okay, so let's say we see our data. The data is, okay, men, 100 people, and what percentage of men like American Gladiators? 90%, no, I don't know. Okay, so let's say 65, okay? So our proportion of group 1, or proportion of men, is equal to 0.65. That's grossly too large, but whatever, okay? Okay, and then for women, you know, the size doesn't have to be the same. Okay, so let's say we asked 80 women, and the number that liked it, 10. No, okay, let's at least have some comparable
Don't be
numbers here,
stereotypical.
okay?
45.
So let's say
Say 50.
40, yeah, okay, we'll go with 50. Okay, so P2 hat is 0.625. Okay. Alright, so we're just making up some numbers here. Okay. So what is our observed difference in proportions? Yeah, our observed difference in proportions is going to be P1 hat minus P2 hat. And in this case, it's 0.65 minus 0.625 equal to 0.025. Okay. So when we look at our picture, we want to know, well, what's the difference? We're expecting 0, but we're getting a difference of 0.025. And what's the probability of getting a difference of 0.025 or something more extreme? Okay. Now I know there's all these other rules, and you probably forgot this one, but because we've got a not equal to sign here, how do I figure out my p-value? I figure out the area in the triangle, and then I double it. Okay. So the p-value is going to be area in the triangle doubled. The area in the triangle times 2. Whole triangle times 2. Okay, that's just one of the rules here. Okay. So the question is, what is our standard error? Now this is the worst part. Alright, okay. And there's like 4 steps involved here. Okay, so finding the standard error, there's no getting around this. It's going to be this ugly thing, alright? And it's p hat times 1 minus p hat times 1 over n1 plus 1 over n2, the entire thing square root. Okay. Oh, it's easy. I got it
Wait,
memorized.
so did you do that one first, the times 2?
No. This is just a reminder of where we're headed.
Oh, okay.
We haven't done it yet.
Okay.
We haven't done it yet. Okay. But then I haven't talked about what p hat is in this scenario. Okay, because we've got p1 hat and we have p2 hat. but we don't have just plain old p hat here, okay? So what is p hat? P hat is the overall proportion. So it's the total successes or total yes divided by total observed. What does that mean? Okay. So this just means overall, if we threw all the men and women that we said out of 100 men, 65 liked American Gladiators. Out of 80 women, 50 liked American Gladiators. Okay, just overall, what proportion liked American Gladiators? Well, that proportion is we have to do 65 plus 50 out of 100 plus 80. How many people did we talk to total? 180 people. And how many liked American Gladiators? 115 total. So my overall proportion p hat is 115 divided by 180. So someone help me out here. I forgot my calculator.
0.6388.
Okay, so 0.6388. So I'm gonna just round out to 0.639. Okay. All right. Is that okay? Or what p hat is? Okay. Yeah. There's a lot of steps. There's a lot of steps, and it's not fun, but this is what we gotta do. Yeah.
I'm sorry, real quick, for P1 hat minus P2 hat,
Yeah.
is that equal 0.65? Where did you get the 0.25 thing? Like, where did that come from? Because I get that for men it was 65, so you got 0.65.
Yeah.
And then so
I-
for 50,
I-
oh, okay,
I
okay,
did
get it.
50 divided by 80, and I got 0.625. And then so when I do 0.65 minus 0.625, I get 0.025. Alright, so my standard error, overall, I have to plug this thing in, and so I get my standard error, and this is just, it's just a big mess, and there's nothing we can do about it.
Is it a new formula, the standard error?
Yeah, it's a new formula. So p hat minus 1 minus times 1 minus p hat over 1 over n1, which is 1 over 100, plus 1 over n2, which is 1 over 80.
Is that what it looks like in the calculator? You have to put more brackets.
Yeah, so, Stephanie, do you mind if I just borrow your calculator? Okay, so, unfortunately, I can't do a calculator tutorial. It's not too bad to do this, and, but I'm just gonna, for the interest of time, do it right here. But, if you've got a fancy calculator, you can just do all of this in, 2 steps here. Okay, so here, when I do this in the calculator, I get 0.072. Thank you. And so, so just trust me that you punch this into your calculator and you're gonna get this number. So then what is my z-score? Yeah, no, my z-score is gonna be 0.025 minus 0, which is my mean, divided by 0.072. So I get a z-score of 0.3 something. I don't know.
0.3472.
0.3472?
Yeah.
Okay. So, 347. So we looked this up in the z table, so I have to look up 0.35 in the z table. And the area that I get in the z table, if I look up 0.35, is 0.3632. So in one tail, I have 0.3632, and then I double it. And so my overall my p-value is 2 times 0.3632. Which gives me 0.7 7264. 7264.
So 0.3632 is just the number you looked up from the table.
Yes. I looked it up in the table and I get 0.3632. Actually, if you look up 0.35 in the table, you get, 60 something. You do 1 minus that to get 0.3632.
Oh, so okay.
Okay.
So even though it's on,
So the problems like this, instead of doing p hat minus q, we're supposed to do the observed difference.
Yeah, you do the observed difference minus the mean, which is 0 in this case.
What is the symbol for that? P hat minus q and.
You can put in p1 hat minus p2 hat. Okay.
So you need to use that p hat formula in order to
Get the
do your
standard error.
correct.
Yeah. Yeah, I know. There's
Just additional
yeah,
steps.
it's more steps. It's more steps. Yes, Sarah.
Is the z-score the same from before?
Um,
Can you give us another thing, like?
I don't want to give you any more formulas, okay? If you
I
draw the
don't know where the
picture,
zero came from.
huh?
I don't know where the zero came from.
The 0 came from the null hypothesis. I put 0 in. The null hypothesis says that there's no difference between the proportions, and this will always be the case for hypothesis test for two proportions. This will always be the null hypothesis, and then the alternative is what's going to change.
So when zero is in all hypotheses and
So 0 is going to always be in the middle for when you're dealing with
Okay.
a two proportion hypothesis test.
Right, and then the 0.025 is what? What is it?
0.025 came from my data. My data said 65% of men liked American Gladiators and 62.5% of women liked American Gladiators, producing a difference of 2.5% or 0.025. Okay? Alright, so what does this mean? We didn't, so let's say we pick alpha as 5%. Alpha 5%, what does this mean? It means, and my p-value is 0.7264. So what do? What do I do with the null hypothesis? Reject or not reject? Okay, so
The
let me-
p-value is bigger.
Reject.
I do not reject. Okay, so remember, this is, what does this say? Alright, so just, think back to like the cheating thing or whatever, okay. So, someone's saying,
Yeah, you don't reject.
if men and women like American Gladiators at the same rate, let's say this, or just some TV show that has just universal popularity, okay? Unlike The Bachelor. Let's say it's some TV show that everybody likes, both men and women, they like it equally, okay? If men and women like the show equally, what's the probability that I take a sample where 65% of one group likes it and 62.5% of the other group likes it, okay? So I'm not getting perfectly even proportions in the two samples. Well, when we do the statistics in the math, it says that, you observed a difference of 2.5% between the proportions. And it's saying, well, if you do the math, whenever you take random samples, you're not going to get the same proportion, and you're going to get a difference of 2.5% about 73% of the time. You're going to, basically, 3 out of 4 samples that you take, you're going to see a difference of at least 2.5% anyway, okay? So what that tells us is that our difference of 2.5%, it's not a big deal. It happens almost all the time anyway. So does that mean do we have evidence that men and women like the show at different proportions based on this sample only? No, we do not. Okay, we need to gather more data if we want to try to make any kind of point.
You do not reject.
At this point, we have no data to say that men and women like the show at in different proportions. Alpha equals 0.05, p-value is 0.7264. Okay, the p-value is greater than alpha. We do not reject the null hypothesis. We We do not have evidence. We do not have evidence that men and women like the show in different proportions.
So since it's greater, does that doesn't mean that every time it's greater, we do not reject it? Like-
Yeah, every time the p-value is bigger than alpha, you do not reject
Oh, okay.
the null hypothesis. Okay. So that was a lot, yes.
So we were supposed to pick the alpha before any of these steps.
Yeah.
Yeah.
So
That's it.
I just defaulted to alpha as 5%. You can pick a larger alpha or a smaller alpha.
Do we ever have to pick a different alpha? Like, can't we always just pick 5? Since it's always.
You know, we'll talk about when you want a big alpha and when you want a different alpha. There's definitely different situations when you want to pick a big alpha, different situations when you want to pick a small alpha. We can't get into the nuances today, but we probably wouldn't want to anyway, right? Alright, so I know we did a lot, and I know maybe this last one is kind of like a lot of stuff. So, you know, try to just do your best as you guys do your homework, and I'll try to help you guys out. So, okay, so we'll stop there, and you guys have a good night.
Thank
See you guys.